Hello everyone, welcome back to Engineering Graphics YouTube channel. I am Professor Swapnil and in today's lecture we are solving problem based on isometric projection. So the problem statement is the figure shows front view and top view of an object. Draw isometric view. This is problem number 4. Already we have solved 3 problems on this topic. Now for isometric projection problem we required length, width and height of an object. Now you can see here this is O point. From O point we can consider 60 plus 30 is the length, it is 90 mm, height is 60 mm and width is 15 15 15 15 into 3 45. So this is 40 mm. So for isometric box we require length, width and height. Along x axis we can mark length, along y axis we can mark width, and along z axis we have marked height h 60 mm. So make a or draw a isometric box first. Now take a O point, mark a O point on a horizontal line and draw 30-degree angle on the both side. 30, 30, 90. So this is x axis, z axis and y axis. Now take a roller and draw along width axis. We can mark a 45 mm line. The width is 45, height is 60 mm, and length is 90 mm. Length is 90 mm. This is 90 mm. So we have marked length, width and height. So by using this length, width and height, make an isometric box. Make a thin isometric box. This is z axis. Adjust the roller along length direction, along x direction, and draw a isometric box. It is the extra lines. Adjust the roller along length direction. This is length direction, and draw a thin line. By using this method, we can draw a isometric box. So this is x axis, this is y axis, and this is z axis. Along length we have marked length, along y width is there, and along z height is there. Now you can see here, for in this figure the front view and top view is given. So O2, O1, 2, 3, 4, this full face, this full profile we can see in the front view direction. This is a x direction, and if you look this object along x direction, we will get a front view. So this full profile O dash 1, 2, 3, 4, O, we can see in the front direction. This surface, this object we can see, this top view we can see from the top side of this object. Now we can draw this profile in this plane. This is first plane. So from O dash we can start our problem. O21 is 90 mm, already 90 mm we have marked. Then 60 mm already we have marked. This 2 to 3 is 30 mm. So from this point number 2, mark a 30 mm distance. Now you can see here 3 to 4. 3 to 4 is a non-isometric line. We cannot directly draw the isometric line in a isometric view. For that we know the point number 3, but for this line we required point number 4 position. So mark point number 4. It is 30 mm from base. So this is point number 4. This is point number 4. This is point number 3. Directly we can join point 3 and 4. So we will get this slant line. So this is the profile. This profile have 45 mm width, 15, 15, 15. So this is a width direction. Already we have marked 45 mm width. So this is point number 2. This point number is 1. So 2 to 2 dash. This is point number 2. 2 to 2 dash is 45 mm. Already we have marked 45 mm. So from 3, find the position, find the point 3 dash. This is also a 45 mm. From 4 also, or from this point we can mark 30 mm distance. Directly we can draw a line going to the width direction. Now we can join the non-isometric line you can see here. Now we can mark this slot. The position of slot is given from O. The dotted line position is from is 30 mm. So from O we can mark 30 mm distance. From O dash mark a 30 mm point, and from this point draw a vertical line up to this slant surface. Now project or pass this point on the slant surface. On this line mark 15 15 15. Distance is 15 mm, 15 mm. And you can see here we are drawing this profile in the top view. Similarly, we can mark a 15 mm 15 distance on this line. Then directly we can join this edge. This is A, B, C, D. So we have drawn this BC line. This is BC line, and this is point A, and this point is D. Now join BA or AB, join AB and CD. Now from A, draw a vertical line up to the base. Similarly, from D, we can draw a vertical line. This is for 15, gap is for 15. You can see. From C, we can draw a vertical line up to this slant line, and from this point, we can draw a depth line. Only the circular hole part is remaining. So all these edges we can see, dark the edges. Here. Now for this circular hole, the position of circular hole is given. The height of that circular hole from base is 30 mm, and from this vertical line the center is 30 mm. So from this vertical line draw 30 mm, and this is a vertical 30 mm. Draw by thin line and draw the vertical 30 distance. This is a 30 mm. So this is the center point of a circle. Now the circle diameter is 30 mm. So required a rhombus of dimension 30 by 30. The diameter is 30. So from the center line, draw 15 mm distance. 15 mm. 15 mm. So for circular hole or circular section, we require a rhombus. Now make a rhombus here. It is a ruler, and draw a vertical line. So draw a horizontal line which is passing through this point. Now by using 4 center method, we can draw this circle, and it looks a flattened circle, or it looks like an ellipse. Now these two are the obtuse angle, and obtuse angle opposite side mid we require to join. Obtuse angle and opposite side mid point. This is also obtuse angle, and the opposite side mid point we have joined. By using thin line, draw this construction. Now this is C1 center, this is C2 center, this is C3 center, this is C4 center. So this method is called as 4 center method. So for this method we require a center point of a circle, then draw a rhombus, find the mid section point, and find the C1, C2, C3, C4 centers. Now take this radius, place a compass at C3, take this radius in compass and draw a 1/4 arc. Now place a pointer at C1 point, take this radius in a compass and draw a 1/4 arc. Now place a pointer at C2 center and draw a 1/4 arc. Place a pointer at C4 and Draw a 1/4 arc. So by this method, you can complete a circle. So we have completed the problem. Now give the dimensions. So this is the length. Length is 90 mm. Total length is 90 mm, but the slot is at 30 mm and the remaining distance is 60 mm. This is 15 distance. This is 15. Height, total height is 60 mm. This height is 60 mm and the base height is, this rectangular strip height is 30 mm. This is 30 mm. So if you look this object from this x direction, we will get a front view. Now you can check in the front view, we can see this profile, 1, 2, 3, 4 profile we can see in the front view. And if you look this object from top, we can see this rectangular part as well as this dotted line indicates the circular hole part, and in the top view you can see this profile 15 mm distance. Try to solve this problem. Thanks for watching.